Okay, so I'm going to walk through homework 6. I have Scholar open in front of me with all the questions right here. I also have the attachment that was given with the homework. This details all the information you need. And I have an Excel file open in front of me. I'm not going to be using too much of Excel, but let's see how that goes. Okay, what are the first few questions? What is the present worth of Project 1, Project 2, Project 3, and Project 4? And the cash flow diagrams for each of the projects is given in the sheet, so all you can just look at the revenues and the expenditures and figure out the present worth. What is the rate? If you read through the entire attachment, you will see that company Y will use an investment alternative that gives it 10% interest, compounded every time period. So you know the more there happens to be 10%, and you can use 10% for each of the time periods. That means if you start off with $1 in that investment alternative at the start of a time period, by the end you will have $1.10. Okay, great. Now let me look at the first project. You go down there. Okay, I've also given you a hint, and I'm just going to go through that hint, what I meant when I told you you can replicate the tables. For example, now for project 1, I have a set of I have a cash flow diagram. I know it goes on for 5 time periods, and I also know I need to calculate the present worth. That is the same for the other projects as well. The most tedious way of doing this is making a table or calculating the present worth of each of these projects one by one without utilizing any of the Excel features. However, there's a way for you to copy your work for one project and use that to do your work for the other projects. I'll show you how that's done. I'm pretty sure most of you already figured that out, but let me just go through it again for the benefit of those who haven't figured it out. Okay, for project 1, end of time period, I have expenditures. I like to break down all my cash flow diagrams into expenditures and revenues, even though for one of the projects you can do a net analysis. You can see what is the net cash flow for each of the time periods. That is fine as well. I just do it this way because I can see everything. So present worth of expenditures and present worth of revenue. I like to break it down. 0, 1, 2, 3, 4, and 5. Okay, what are my expenditures? I have 50,000 at the end of time period 1. Oh, sorry, at the end of time period 0. I have 2 revenues after that, 20,000 each. I have another expenditure, 50,000. And finally, 30,000 and 20,000. Okay, what is my present worth of expenditures? All I have to do is say equals to that column divided by 1 plus 10%, that was my alternative, raised to the power 0. So this column is going to give me the exponent for 1 plus 10%. I'll use a fill handle. I'll use a fill handle, and Excel does the rest for me. Present worth of revenue, that's also easy. 10% raised to the power 0. Use a fill handle again, and that's done. Okay, what is the total? The total present worth of all the expenditures happens to be, this is for project 1, 87,565.74. What is that for the revenues? 67,000. Okay, so the present worth of revenues is less than the present worth of expenditures, and this should be the case for at least 3 of your projects. There is one project which gives you a higher present worth as compared to the other 3, or it has a positive present worth. Okay, so what is the net present worth? Present worth of revenues minus present worth of expenditures. It's negative, so it's a loss-making project. However, you're not concerned about that. You're only going to check what is the economic feasibility of the project, and you're also going to assume that the company is going to fund one of these projects. Having said that, I know I have to perform the set of operations for Project 2, Project 3, Project 4. Is there a way for me to minimize my efforts? Certainly there is. I've already entered the formulas for this table, so all I'm going to do is copy it and paste it in another region, and just name this Project 2. And I'll modify my expenditures and revenues accordingly. What is it for Project 2? 90,000. No expenditures after that, so 0, 0, 0. What about the revenues? 30,000 at the end of time period 1. Nothing for the end of time period 2. 35. for the end of time period 3, nothing for the end of time period 4, and finally 40,000 for the end of time period 5. So Excel has automatically calculated the present worth of expenditures, revenues, and the net present worth for me. All it did was copy the same format of the formulas in this table and it applied it to this table. So this makes life a lot easier. And that should minimize your efforts for the first 4 questions. Okay, what is the next question, the 5th one? Based on the information given, which project can company Y afford to fund? Also called a feasible set of projects. Okay, if you read through the information given, you will see that company Y can set aside at most $95,000 at the end of time period 0 to finance one or multiple project proposals. Okay, when we're talking about which project should be funded, certainly company Y would love to fund the project that has the greatest revenue, or it maximizes revenue, so on and so forth. But that is not your concern. What you're concerned about is if the company is going to set aside money to cover all its expenditures for the future, which projects can it afford to fund? So all you have to look at is the present worth of expenditures. Why present worth of expenditures? See, the company has an alternative investment that gives it 10% interest. So for example, for project 1, which has one expenditure now and another expenditure by the end of time period 3, the company doesn't have to set aside $100,000 to cover these expenditures. It can set aside $87,000 now, out of which $50,000 is going to lose straight away, and the remaining money, which is $37,565, it can deposit that in the alternative and then withdraw that by the end of time period 3. Thus, it minimizes its expenditures. That's the whole idea. So based on that information, you have to figure out how many projects. Now, can the company fund only one project at a time? Can it fund multiple projects? So on and so forth. Essentially, you're trying to figure out what are the projects the company can fund and which it cannot. Okay, so that's not going to be too tough once you have all the tables set up. Okay, what is the next question? From the set of feasible projects, or the projects which the company can fund, which project has the highest ERR, or the external rate of return, and what is the value of the ERR for that project? I already have my table for present worth. For ERR, I need the future worth of revenue, so I'm just going to create another column here for project 1. And what's the future worth going to be? That's going to be the revenue at that certain time period times 1 plus the interest rate, raised to the power, the total number of time periods is 5, minus the time period which the revenue occurs. And once again, I'm just going to use my fill handle and let Excel do the work for me. Let me just put that in accounting format. So what is the total revenue? What is the best the company can do if it chose to invest in project 1? By the end of time period 5, the company, using its alternative, can have at most $108,000, $108,902 by the end of time period 5. That's great, because now the ERR, or the external rate of return, becomes very easy to duplicate. Okay, so what is the ERR? That is saying if you can set aside, you're looking at an imaginary account now, if you can set aside $87,565.74 now, and you want $108,902 by the end of time period 5, what is the rate of that imaginary account? So that's simply going to be future worth of revenue divided by the present worth of expenditures, 1 divided by 5, because that's the number of time periods, minus 1. And that's all there is. It's as simple as that. And I don't have to sit down and duplicate this for the other tables. All I'm going to do is copy this table here, paste it there, so you see Excel did that for me automatically, and do the same for the ERR. And I'm done. So it barely took me about, when did I start? I forget when I started, but it's not taken me more than 15 minutes to do this. And even if you have 4 projects, you should be done with the first 6 questions in about 20 minutes. It's not going to take longer than that. Use the shortcuts in Excel. Utilize Excel to minimize your efforts. Okay, fine. What is the next question? Out of all the feasible projects, one project is picked as a base alternative, also called the basis. The base alternative requires the least amount of money to be set aside at time 0 to cover the expenditures for the entire project. Which project is a base alternative? Now, you've already calculated for each of the projects the present worth of the expenditures. Look at the present worth of expenditures. All these projects are supposed to achieve the same set of goals. All you're looking for is which project requires the least amount of investment on company's Y side as of now. And based on that, and that project which requires the least amount of investment is essentially your base alternative. Okay, fine. What is the next question? If all feasible alternatives have an ERR less than the MAR, okay, so I'm giving you a clue here. If you sit down and calculate the ERR for all the projects, you will see, for all the feasible projects at least, you will see that the ERR is less than the MAR. So what is the main point of doing this assignment, or what's the main point of solving that question? In real life, there may be a time when the revenues don't match up with the expenditures and you have lesser revenues compared to the expenditures. Does that mean the ERR method is useless? No, it's not. You can still derive a lot of information from the ERR. Now, I already know how to pick my base alternative. That's the project that has the least expenditures. How do the other feasible alternatives compare to the base alternative? And why would I be interested in doing that? Certainly, I want to minimize my expenditures, but I also want to know if I can set aside more money, or if I have the capacity to incur a little more expenditure, would it be worth it? By using the ERR just plainly on the projects as I've shown here, you're not going to get that intuition. ERR is supposed to be greater than the MAR, which happens to be 10% for us. So how do I work around that? How can I somehow derive intuition from the information I have? And as the question tells you, look at the incremental cash flow diagrams. Those of you who don't remember what incremental cash flow means, I'm just going to give you a quick example here. I have two projects, and project 1, project 2. And out of these two, if I was just looking at these two projects, remember, I'm not talking about the entire answer. I'm just looking at these two projects for now. If I had to pick one as my base alternative, that would be project 1, because the expenditure required there is less than the expenditure required for project 2. Okay, now that I have the base alternative, all I'm going to look at is how much more do I have to spend for project 2, and how much more do I stand to gain by investing in project 2. Why is that? But if project 1 has a lesser expenditure than project 2, by default, I'm inclined to invest in project 1. However, is there a way for me to figure out if project 2 is worth my investment or not by using the ERR? By looking at the present worth, certainly, you already know that project 2 is worth your time. It has a higher value for present worth as compared to project 1. So, using the present worth method, you are inclined to invest in project 2 as compared to project 1. Can I use the ERR method to do the same? Certainly. So, I'm going to look at the incremental cash flow here. This is not, I'm not going to say if this is, what your question asks. What does your question ask? So if you read the question, you can see, you can guess right now that project 3 is going to be your base alternative. I give away the answer there, but doesn't matter. But I'm not going to use project 3 because I'll be giving away more answers. I'm just going to use project 1 for now. And incremental cash flows. So I will have expenditures, I will have revenue, I will need a present worth for expenditures, and I will have a future worth for revenues. Okay, fine. So project 1 happens to be my base alternative. This is saying by default I'm inclined to invest in project 1, and I'm going to check incrementally how much more do I need to spend for project 2 and how much more do I stand to gain for project 2. Okay, fine. So let's look at the first one. Expenditure-wise, I certainly need to spend more for project 2 at time period 0. So expenditure will be 90,000 minus 50,000. Okay, great. Now I can apply the fill handle here, and Excel will replicate that effort for you. So you see, this is saying, at the end of time period 0, if you invest in project 2, you certainly have to spend 40,000 more. However, if you choose to invest in project 2, you will have to invest 50,000 less. And how did I derive that? I have a negative expenditure here. Negative expenditure means you stand to gain more money. So that is telling you if you choose to invest in project 2, you will have to spend 50,000 less at the end of time period 3. So that is great. Can I do the same thing for the revenue? Certainly. At the end of time period 0, I have 0 revenue, that's the cell, and for project 1, it happens to be that cell. And I'm just going to replicate that again. Okay, great. So let's just look at what this is saying. At the end of time period 1, if you choose to invest in project 2, you stand to gain 10,000 more. Is that true? Yes. For project 1, I would have gained 20,000 by the end of time period 1. However, if I chose to invest in project 2, I would get 30,000. So that's a gain of 10,000 for me. Going by the same logic, by the end of time period 2, I would have gained 20,000 for project 1, and I gained nothing for project 2. So that registers as a negative revenue, which means that counts as an expenditure for you, or a loss. I shouldn't say an expenditure because you're not spending this money, but this would count as a loss. And if you just keep doing that for the others, you will see where the logic lies. Okay, so having said that, keep the signs the same. Don't change the signs. And using that, calculate the present worth of expenditures. Divided by 1 plus 10% raised to the power. I'm going to go all the way to the first column there. And once again, I'm going to ask Excel to duplicate this for me. So this is saying the present worth of expenditures is 40,000. That means you stand to lose 40,000 more if, or you have to spend 40,000 more for project 2. However, in terms of the current money, or in terms of money in the present, you stand to gain 37,565.74 at the end of time period 3 if you choose to invest in project 2 instead of project 1. I know because of the speed at which I'm speaking or what I'm saying, it might confuse you, but the only logic I'm following here is I know I have to invest in project 1. That's my default because it has the least present worth value for the expenditures out of these two. And all I'm checking is if I chose to invest in project 2, how much do I have to spend more and how much do I stand to gain more? That's all there is, okay? Future worth of revenues. That's equal to the revenue times 1 plus 10% raised to the power 5 minus the time period which it occurs. And I just drag that down. So I have the net present worth as 2,434. So that is saying, in terms of the present, in terms of money that can be described in the present, you would have to spend 2,434 more for project 2. And in terms of the money that can be described in the future, you stand to gain $17,371 more if you chose to invest in project 2. If you see this, then you can guess straight away that the ERR is going to be greater than the MAR. And let me just verify that for you. And in fact, it is. So using this, certainly I can claim, yes, the incremental cash flow has an ERR greater than the MAR, so certainly project 2 is worth investing in as compared to project 1. So I derived the same intuition out of using the ERR as compared to using the net present worth. And that's all there is to this assignment. Now this is called, what I just did using the incremental cash flows, is called the incremental investment analysis, or ranking all your projects based on their expenditures. What does ranking mean? I rank all my projects based on, in ascending order of the expenditures. So rank number 1 is a project that requires the least investment right now, and rank number 2 would be, higher, so on and so forth. And if you use incremental cash flow analysis, you can easily see that the incremental cash flow you would stand to gain or lose by investing in project 2 over project 1 has an ERR greater than the MAR. So it's giving you the same result as the present worth. If I looked at the present worth, I'd say yes, project 2 is better as compared to project 1. And by doing the ERR, I also get the same analysis. Would I get the same answer by just using the ERR, or for that matter IRR, on individual projects? No, I wouldn't, because individually, for each of the projects, except I'm not sure if this is the same for project 4, I'm only talking about the feasible projects. For all the feasible projects you have, the ERR should be lesser than the MAR, because all of them have negative present worths. And that's the logic I'm following. So I'm trying to extract as much information as possible, and I'm trying to look at it from different angles. That's the main idea behind this. And I'm going to talk about, I will talk about ranking all these projects again on Monday, but by doing this assignment, it should be clear to you what I'm trying to achieve. Okay, that's all I have. Question number 9 should be easy to solve if you know all the rest. And I'll see you in class tomorrow. Oh, sorry, day after tomorrow.